Welcome back to new exercise, two-stage reduction gearbox. See here, this is input shaft and this is output shaft. This is two-stage gearbox which reduce the speed from one end to other end. You will see the first input shaft speed is higher, but the output shaft speed is lower. Here we will make each and every part separately and we will assemble at the end. Welcome back to another exercise. In this exercise, we are going to make two-stage reduction gearbox. So here we will make left-right case. Then we will develop some gears. There are 4 number of gears including pinion. Then some small bushes and some circlips are there. So look, this is the gear reference gear A, B, C, D. These all details: number of teeth, module, pressure angle, pitch diameter, outside diameter, root diameter, base, face width. Everything it is there for all the gears. And see, these are the total 13 number of parts. And we are going to start with this part. This is the part number 13, gearbox right side, left side. These are the casing. You will see all dimensions are in millimeter, NC metric standard for gear. Okay, so let's see this drawing carefully. This is a little too much dimensions, that's why it looks difficult. Now we will make outside to outside casing first. Now look, this diameter radius 87. Now these radius 70. Now distance between these 91. Then here one more radius circle, 31 millimeter is the radius. And see, this is a 5 millimeter thick ring. You will see in section view, we have a section view for this. Look at top, 5 millimeter. And the depth of this ring is 26 millimeter. So let's do this first. Look, from here to here, 39 millimeter, and this circle are in you can say in one line, in horizontal position, top. Let's do this. Now I am going to activate here front plane sketch, activate circle. Now first circle I am going to start from here, and that is 87. This is the radius into 2. Fine. Similarly, I am going to activate the another one, 70 into 2. Okay, now let's one more here, 31 into 2. Exit. Okay, let's make important relation. Select these 2 points, horizontal. Smart dimension, let's define this. And the angle is 91 millimeter. Similarly, these vertical distance shows 39 millimeter. Okay, now let's activate center line, and I am going to connect with this point to this point. Cancel. Okay, now make sure this one is in horizontal position. Okay, let's drag here. Okay, you will see some more dimensions for this given. Now let's check here. This center to center distance 73 millimeter, because here we have one pinion and one gear here, and both pitch going to collide, and the distance between both pitch is 73. Similarly, this is on left side also. So we will do this. Smart dimension, and let's make center to center distance 73. That's fine. Now activate here trim entities, power trim, and just press and hold the left mouse and drag, and we have a common area. See? Okay, now this is our outside area. Now corner fillets are 10 mm. Now you will see here. all are 10, even inside outside. So we will do this one. Then we will add this also. You will see here outside radius R7, 3 numbers, and center distance 95, 77, and there are 3 types of this, and this is going to be throughout. Okay, let's make fillet 10 millimeter, and let's check all edges. That's fine. Okay, now activate offset, make 5 millimeter and select this one, and I want to make inside, so change here, make sure we selected change, otherwise you have to select all the lines one by one. Reverse, see here, that's it. Okay, now we have a closed geometry. Okay, let's do this. Extruded boss base. Now this is going to be 26 millimeter. Fine. Again use the same sketch. Extruded boss base. Now here we have selected contour. In selected contour, let me choose the outside edge, and here make depth 5 millimeter inside. Okay, that's fine. Now select this top face, sketch. Now here I want to activate something like a circle, and let me add one circle here, 7 into 2, 14 millimeter. That's fine. One I am going to add here, 14. We have 2, and one more we have here, 14. Okay, now let's define this first. Let me move this one here little. Smart dimension, distance from here to here, the horizontal distance 40 millimeter. Now similarly select this one and select the outer edge, and these distance given 34, and distance from here to center, the vertical length, it is showing 20 millimeter. That's fine. Now again one more dimensions given here, 94 millimeter, this point to this point, 94. Similarly for this, because they both are from same, 94. Now let me select this one with this distance given 77. Okay, now let me select first center line, connect one line from here to press Ctrl key, and this line make concentric. Fine. Now let me activate here line, and I'm going to draw some parallel line like this. Okay, let me select this center line, and these two outside line, make sure symmetry. That's fine. Now, okay, this is tangent, it's no issue. Okay, these make dimension something like okay, create one more relation, parallel relation to this. Select these two lines, parallel. Okay, now that's fine. I have to do for all. Activate line. Okay, let's create, press and hold shift key. Let's create horizontal relation, symmetric relation. Then again select these two lines, make parallel. Now select this curve or this line, make tangent, so that our drawing will be fully defined. That's the what our aim. Okay. Okay, again select the center line, press and hold shift key, select these two lines and make relation symmetric. Again select one line, center line, parallel. Select this curve or this line, tangent. Still okay. Still not tangent. Let me check. Okay, these are the parallel, but let's make this one equal. That side. Now let's extrude this line also. Extruded boss base. Now here we have to choose all close profile. Let's say this one, this one, this one. See. Okay, let me check all these. There are too many close profile, that's why we have to select carefully one by one all. Okay, make 26 and change direction towards this face. Okay, see, now there is some small also. Outer CR5, there are 4, 1, 2, 3, 4. How we will place this one? Let's see. Again, I am going to choose the same face, sketch, sorry. Activate circle and let's place one here. Radius is 5, means diameter 10. Okay. Now let's create important relation. Select this one and this arc, tangent. Now select this arc, not center one, and this one, tangent. See, this is fully defined. I am going to select this arc, hold shift key, this one, tangent, tangent. Similarly, I'll do for all these 4. Tangent. Now select this arc, tangent. Don't select center one. Okay, all things are fully defined. Now how much this depth? Only 5 millimeter. Extruded boss base, make it 5 millimeter. Just check the direction. Reverse. Okay. See. Now first I am going to choose fillet, constant type fillet, and here keep fillet parameter 10 millimeter radius. Now first I am going to cover this bigger one. Don't select face in this condition. because we have too many edges here. Okay, let's check. Okay, now then, now like the corner radius for a smaller one is 2 millimeter. Then there is a hole, 4 diameter hole, and for this 6 diameter hole. Okay, so let me again activate fillet radius 2 millimeter only, constant type. Okay, this is really minor to select. Oh, this. It's difficult to select actually. Okay, let's check which one balance. Okay, that's fine. Okay, now hole I am going to add with hole wizard. Simple activate simple hole, and ISO standard, that's it. Simple drill size and hole diameter. According to our drawing, there are 4 dia and 6 dia hole. So first I am going to make 4 dia hole. Make throughout or choose up to next. Fine. Now go to position and select one face. Okay, let's keep cursor over here and you will see center point for this. Now look, this is fully defined sketch. Let's check. Okay, oh, that's it. Again I am going to activate hole wizard. Same hole, this time the hole size is little bigger. ISO standard and everything is same. Drill size, hole up to next. Position, again I am going to select the same face. Keep cursor on edge and you will see center point. Now just tilt and see. This is fully defined sketch. Here we go. The holes are created. Now let's make some back plate. Now there is some holes. So first we have to make the back plates. You will see in dotted line, these lines shows 57, 52, 52 on same position. And how much we need to extrude this one, you will see here 12 millimeter. Okay, then we will add ribs. We have 5 millimeter rib here, 5 millimeter rib here, 5 millimeter, 5 millimeter. These all size have 5 millimeter rib, and this rib size from here you can check 15 millimeter. If you exclude 5 millimeter from the thickness, it's become 10 millimeter rib, and width 20 millimeter. See here. So the things are clear. Now let's select the back surface sketch. Now here I am going to choose this one. Okay, the first one here is 57. The second one, just keep cursor here and you will see center point. 52. Again keep cursor and you will see center point. 52. Fine. Okay, let's extrude this one. Let's make 12 millimeter. Change this one to, say okay. So let's use right plane, sketch, activate line tool, connect from here to, make sure you select from here and make little inside. Okay, let's make the depth 10 millimeter and the length, total length 20 millimeter. Look, this seems fully defined. Let's make 2 millimeter inside because there is some error if it's difficult to create rib on circular edge. See, this is circular edge. Okay. Okay, let's make rib. Go to rib. Now look, this is moving upside, so here choose flip material size. Now thickness 5 millimeter both side. Okay, and here we created rib. Okay, let's try to make 3 number of ribs. So I'm going to use circular pattern. Now I'm going to choose this one. Here I am going to choose 3, but instances space, let's say 90 degree. That's it. Keep instances space, uncheck equal spacing, 90 degree between 2 ribs and 3 number of instances. Say okay, and that's it. Now let's make a plane. Right plane. Now create a plane. Now center to center distance here 91 millimeter. Make flip side. Okay. Now let's make one rib here. Length, let's say keep little inside because of this circular edge. Horizontal and vertical distance 10 and 20. That's it. Now let's move rib. 5 millimeter thickness material, move both side. Now see the arrow, it's moving perfect size. Okay, hide this. Okay, we found some step here. Let's check what. Edit. Actually, this is our circle. We considered this one. See, so delete this relation, just move here and move up to here. Now that's fine. Just rotate component. Okay, exit, and that's it. Now here we need to make on 3 directions. Similarly, I am going to use circular pattern. Circular edge, I am going to choose this one. Now feature to mirror, let's choose this one. Instance spacing, now space between 2 90 degree. and 3 number of instances, but change reverse direction. Okay, that's it. Okay, let's check. Okay, this is going to be at center. Sketch line. Now both side, make sure horizontal, and let's define distance 10 millimeter. Okay, now distance from here to outer edge, make to at least 2 millimeter, 1 millimeter, no issue. Again use rib. Now let's check, the arrow moves upside, 5 millimeter thickness both side, flip side. Okay, and here see, the rib is created. Okay, let's make back side. See, the small radius 2 millimeter and this corner radius R10. You will see this all small radius, you will see. Even this corner also have radius. Okay, let's make this hole. You will see here, this is counter bore hole, 47, depth 12 millimeter, 27 throughout. Then here depth 42 millimeter, diameter 42, depth 12 millimeter. And similarly here also the same. Okay. So let me change hole wizard, and I am going to choose this one, legacy hole, and here I am going to choose counter bore hole. Now the normal diameter 27. Now for depth it's through all, so I am going to keep through all. Now counter bore diameter, how much counter bore diameter is given? 47 millimeter. Then depth of this counter bore diameter, it's given 12 millimeter. Okay, position. Now select this face. Now place at center, right click, select and exit. Okay, see, again the same hole wizard, legacy hole. Here choose not counter bore hole. This is the simple hole. Okay, let's make simple hole. Diameter, it's going to be 42, and depth here, okay, here change blind. Now make depth 12 millimeter. Now I want to place at this, so choose position, select this face, just keep cursor and you will see the center point. Right click, choose select and exit, say okay. See, again same thing, hole 42, 12 depth, blind, position. Now select this face and I want to place at center of this, keep cursor over here. Again let me, okay, now right click and exit. See, fillet. Now the first fillet is going to be 10 millimeter. Constant type fillet here, symmetric 10 millimeter radius, and I am going to choose this. Fine. Now let's again fillet, and this is going to be a small fillet 2 millimeter radius. First I am going to choose all vertical. Okay, let me check. 2, 2, 2, 2 here, 2 here, 2 here. All are selected. Okay. Again. And everything is same. Now let's select. See. Now it's easy to apply. No need to select all the. See. Okay. But that's fine. Okay. Now we hole also applied. Everything is done, I think. So let's go to material, edit material, alloy steel, apply and close. But if you want to change this appearance, double click. Okay. Now let me save this one. Now I am going to save on desktop, create folder, two stage reduction gearbox. See, enter, double click, and this is going to be part 1, and make gearbox left side. Sorry, this is going to be right side, not left side. Right side casing. And let's say this is part 1. Let's make this second part, gearbox left side casing. Now see, this is left side casing. This casing is same, only the difference there is a counter bore hole and this part. This part we have only one hole, see 42 depth 12, but this part we have counter bore hole. So only we have to do this one, 42 depth 12 already there, only make hole 27 throughout. So we will use the previous one, make mirror, then we will do it. Okay. Now this is our main casing. Now here choose mirror. Now face, I am going to select this face as a plane. Now select the body, select this body, unmerge. Okay, plane 1 selected, select the body, unmerge this result, uncheck, so that we will get 2 body, say okay. Now here we have 2 body. Now this side body I want to delete, so select, drop down this body and choose which one. Okay, this side body, right click, delete, keep body. Now here option delete body, make sure we selected this body, say okay. See, this is our left side. Now let's make hole here, make 27 diameter hole, activate extruded cut feature and make throughout hole. Okay. Now look, this is the left side. Now let me, don't save, otherwise your first file will change. So simply choose save as. Now here I am going to choose 2, in right just change left, left side casing, save. Now let's make this gear, we will make during assembly. So let's make other small parts, like see, third gear shaft, stopper tube, cosmetic bearing. Now look, part 1, this is the part 1, third gear shaft, stopper tube. So 4 millimeter 30 20. Okay. Then the second one is cosmetic bearing. Here size is given and here the quantity. Okay. So 25 internal diameter, 47 outside, and corner fillet 0.5, thickness 12 millimeter. Similarly here 20-40, depth 12 millimeter, or corner fillet we will keep 0.5. Front plane sketch, activate circle. Now first I am going to change here the outer diameter 30, enter. Now activate extruded boss base. Keep end condition blind and depth only 4 millimeter. Look. Now this material I am going to change. Alloy assess, apply, close. If you don't like, just simply change it. Steel, polished steel. That's it. Now let's save this one. This is save at desktop. Stopper tube. Now let's make cosmetic bearing front plane sketch, activate circle, and let me draw here two circle. The outer one 47, then inner one 20, 25. Exit, activate extruded boss base, and here the depth is 12 millimeter. Keep end condition blind, depth keep 12 millimeter. Okay. Fillet 0.5, constant type fillet here, symmetric, and I'm going to choose this face. Okay. Now material is going to be same like alloy steel, but appearance I am going to change. Let's say blue. It looks more practical, easy to identify, edit feature, and select inside also. Okay. Now let me save this one. This is going to be part 4. Cosmetic bearing, and size is actually 25, 47, 12 mm. Now I am going to do little changes. Only I am going to double click on this 47 and change 42. Now rest everything is same. Okay, internal also let's make 20. Okay, 42, 20. This is part 12 millimeter. Now let me save as. Here I am going to change 20 minus 42. Cosmetic bearing 12, 5. Save. Now let's make what next. Now there are 4 number of gears, and these we will make during assembly, and we will edit also during assembly. Output shaft, part number 8. Okay, this is the output shaft. You will see outer diameter 25. From here to this corner to this was 68, but there is 1 millimeter groove here. Then this outer one you will see from here 35 millimeter, the outer diameter. Then there is this kind of shape you will see from here 30 diameter, 25 diameter, depth 15, this overall length 87, 25. Groove at 65 1 millimeter, 15 millimeter. Okay, this groove depth 23 millimeter. That's fine. Now I am going to choose here front plane, sketch. Now activate line tool. Now let's do like this. And connect with this. Make sure this is construction line. Again, this is going to be horizontal. That's fine. Now let's define the first diameter. See, this diameter 25. This is going to be 35. Now this is going to be 30. And the next another end it's going to be 25. Fine. Okay, now overall length, this is going to be like 87. Okay, now this one going to be 4. This is going to be 15. Fine. Now this one going to be here 68. That's it. Now activate here revolve boss base. Now due to this construction line profile is open, so system asks, would you like this sketch to be automatically closed? Say yes. By default, system took this construction line as an axis of revolution. We need complete 360-degree circular body, so keep angle 360, keep end condition blind. Even direction no need to define anything because okay. Now again let's say front plane sketch. Now here we have a groove, a small groove. Oh, actually we have to create here a rectangle. Now this depth 1 millimeter only. Okay, let me make one center line. Again create rectangle, and I am going to create something here. 1. Okay, let's make the diameter 23. Okay, this is perfect position. Now this one we have to define, and this one is going to be 65 millimeter from here to here. 65. Now it seems fully defined, this sketch. Go to feature and activate revolve cut. Now look, by default system took this center line as the axis of revolution. Just rotate, you'll see the preview. I'm going to cut 360 degree, a complete circle. Say okay. Look, now let's cut this. I want to select this face, sketch. Now let's select line. Let's make one vertical line. Again press L key in your keyboard and draw one line, something like this. Okay, now the circle, it's going to be 30. That's fine. Mirror, here choose line, mirror about this line. Okay, make this line construction line. Trim entity, power trim, just press and hold the left mouse and delete extra lines. Now the center distance or gap shows here, let's say how much, 25. Okay, still not okay. Select the center one and select both the lines. Make relation symmetric. Now it seems fully defined. Extruded cut. Now here I am going to choose up to next. Flip side to cut. Okay, let's choose up to surface and choose this surface. And if we choose flip side to cut, see, this is going to cut this. Okay. That's done. Edit material, and I am going to apply alloy steel, apply close. If you want to give something like I want to give some other, okay, this seems good. Dark silver plating. Save this one, and this is going to save part number 6, and this is going to be output shaft. Now we have here one more part, output shaft stopper tube. 35 outside diameter, inner diameter 25, and depth of this 21 millimeter. Okay. Front plane sketch. Now activate circle and draw 2 circles at center. Now first outer diameter I am going to keep here 35. Activate extruded boss base, keep end condition 21. Say OK. Now right click, edit material, alloy steel, apply close. Appearance I am going to change from here, polished steel. Now let me save this one. Output shaft stopper tube. Let's make next part. We have here 2 retaining rings. Either we can take this from system or we will make. This is not available in SolidWorks, so that's why we are going to make it. Retaining ring snap ring 20 mm and 25 mm. 4 numbers, 2 numbers. So let's make first 20. Let's make bigger, then we will edit 2 smaller. Okay, part number 10. Let's start with this. See, internal radius 10 mean diameter 20. Outer diameter 12.5 into 2, 25. And see the center between these 2 circles 1 millimeter. Okay, I'll tell you how. Now this head 8 millimeter, cap 2 millimeter. Now hold to this corner 1.5. Similarly 1.5 downward side. Now from top to center of this inner circle 13 millimeter here. corner radius R8, and there is one more small radius, and thickness 1 millimeter. You will see here, and there is a two holes. These holes diameter 2. So let's do this. I am going to select here front plane, sketch. Now activate circle, and let me draw here two circle. Now first circle, outer one we will draw 25. Okay. Now let's make inner one. So inner one, make distance little up, 20, enter. Right click or press escape key to out. Smart dimension. Now let's make distance between these two 1 millimeter. Fine. Even though make both in one line, horizontal. Okay. Now let me draw some center line. This is going to help us. Again, let me draw one line. Connect up to here. Mirror entity. Now select these two lines. Make sure you selected copy, and for reference select this one. Okay. Again, I am going to select here 3-point arc, and I am going to connect from here to this. Right click, exit. Now select this one and this, both the curve, tangent relation. This is important relation. Smart dimension. Let's make this. Now this is going to be 8 millimeter. That's fine. Mirror entity. Select this one. Copy. Okay. Again, smart dimension. Now let's see distance from here to here. It shows 13. Fine. Now distance from this point to this point shows 8 millimeter. Now distance between these two, 2 millimeter. Look, it seems fully defined sketch. So activate trim entities, power trim, and let's trim unnecessary lines. So let's say press and hold left mouse and drag over the line. And see? And here we have a closed geometry. Okay. Now let's make some hole also here. 2 diameter hole. 2, enter. Right click, choose select out. Smart dimension. Now let's make distance 1.5 from both end. Okay, let's also mirror this circle. Make sure copy, center line. Okay, now we have a perfect clip. Now let's that's fine. Extruded boss base. Keep end condition blind and thickness 1 millimeter only. Say okay. Right click, edit material, alloy steel, apply, close. Now for I want to give some color to this. Let me apply some green color and how it looks. Okay. Perfect. Now let me save this one. This is going to be part number 8. Retaining ring. Now here I have to mention this all dimensions. Snap ring, and this is going to be, let's say, 20 mm or 20 millimeter. Save. Okay. Now this is the one. Now there is bigger one. Look, there is small changes. See, outer radius 15, before 12.5, before 10, now 12.5, means 25, 30. Gap is same 1 millimeter. Hole size also 2 millimeter. Everything is same 2 millimeter. Now this corner radius become 28 and height 16 millimeter. Fine. and 2 millimeter this one. So let's change little, edit sketch. Now first outer one, double click, 30 millimeter. Okay, it's going to, let's say 16. Okay, let's make this one 28. Let's make this one 10, and the inner one, double click, 25. Now let me check what else we forget. Oh, this is not 20, this is 30 actually. Okay, that's fine. Now whole size, everything is same. Now look, we have fully defined a sketch. Simply exit. Now look, this is the bigger ring. Now this one, click save as, otherwise previous one will, you will change. 9, and this one 25 mm. Let's make little gap. Retaining ring, snap ring 25 mm. Say okay. Now let's go and start assembly. This gear we will use tool library, and then we will modify it according to drawing. Now these are our assembly. These are all 4 gears. This is the first gear, pinion, then gear B and D, then there is one third gear. Now this is the main shaft, output shaft. You will see output shaft, this one we are going to made here. Now these all are cosmetic bearings we applied here, retaining rings. We will see how to do in assembly. So let's do this. Let's open file, new, and here I am going to choose assembly. Say okay. 2 stage. Now from here let me change large icon, gearbox right side casing, open. Now before going to place, let me activate origin. Now just move cursor over origin and these parts going to overlap. See, click. Now parts located at origin point. Now just simply uncheck. Let me choose plain white. Let me change the image quality so that we will get a sharp image. Okay. Now let's insert component. Now let me choose here control key and select these 2 cosmetic bearings. Okay, the bigger one for this, because this diameter is let's say this is going to be 47. Just check this one. Okay, this is going to be 47. Activate matte tool. Now select this one and this upper. Make relation concentric. Now let's select inside face of hole. Now select back side. Okay. Now this is fixed here. Now select again same outer hole and outer of this hole, concentric mat. Now we need to fix with this wall. So I am going to select back of bearing and select this face, coincident mat. Okay. Now I want to make some more. So just press Control key, click and drag and copy. See, we copied up same part. Again, mat. I am going to select this outer face and inner face of circle. Make relation concentric. Let's drag it here. This face and inner face. Coincident relation. That's it. Now let's bring some more part. Now here we need retaining ring, snap ring 25 mm. Okay. Press control key, output shaft. Again press control key, output shaft, stopper tube. These three are important. Open first part, second part, third part. Now let me rotate this part. So here I am going to use rotate component, and I am going to keep, okay, I am going to keep like this. Okay. Now I am going to select mat. Let's select this face and this internal face. Make relation concentric. Fine. Similarly, I am going to select this face, internal face, and the ring internal face. Let's see where the ring concentric. Fine, but still not. I am going to select the back face of ring and back face this. Okay, now this is going to fixed. See, now these face going to attach with this spring. So let's take it out, select this face and select bearing face, coincide. Okay, similarly there is one more part, select internal face and this face, concentric mat. Fine, take out, select this face and choose retaining ring. Now just see the preview, exactly place. Okay, see, now the movement is depend on this output shaft on gear, so we will connect it. Now for here I am going to bring snap ring and stopper, third gear shaft, stopper tube. Okay, open. Okay, let me save this assembly, otherwise we make some problem. Okay, so we will give the name to stage reduction gearbox assembly. Okay, now let's start to bring the bigger gear. You will see in assembly the bigger gear is gear D 1.3 is. Now we will use toolbar and NC metric standard. Then later we will cut all this. Now here gear D, you will see these all options, number of teeth 73, module 2, pressure angle 20, pitch diameter 146. These all are the things. Face width 15. Okay, this is important, and this is by default system, we can take it. Then later we will cut this hole. There is a 6 number of 30 dia hole. Then there is a small holes, let's see, 6 dia 10 hole. Then there is one hole cutout 25, you will see here. This is 40 30, we will see. Then there is a one big hole 125, depth 3.5. So both side we will do this, corner radius, this all. Let's see what can possibly do. Now we already saved, just go to toolbox, NC metric, power transmission, gears. Now from here I am going to use helical per gear. So drag. Okay. Now first module is 2. Number of teeth for this 73. Now pressure angle 20, face width, hub style keep normal because I want to make shaft here. Nominal shaft diameter, this one as it is, we will later pave it, say okay. And system asks, would you like more, say no. Now click this one, open part, say yes. Now let me change plane. Now I want to modify this one according to that. So I am going to select this face, sketch. First I am going to make a outer hole. 125, enter. Now here I am going to choose extruded cut and make depth 3.5. Okay. See. Now let's make this something image quality better. See the again I am going to use the same sketch, extruded cut, but start plane, surface plane, backside. Now you will see the preview. This is going opposite direction, so change direction from here, depth 3.5. okay. See, we trimmed. Select this corner, fillet 0.5, fillet type constant size, symmetric. Now I am going to select both the corners. Okay. Now select the center one, sketch, circle, and let's draw here. And at center there is a 40 dia circle. Extrude. This side 3.5. Okay. Even though you can do similarly for other side, so I am going to use the same sketch, extruded boss base, cancel it. We will use the same feature also. Direction 2. In direction 2, this is 15. So the thickness going to become 15 minus 7. This is going to be 8 plus 3.5. Say okay. See. Sketch. First let me create here for hole a circle. Now the diameter for this circle given 30. Line. It's quite difficult to see. Oh, it's going to tangent, delete this. Okay, let me do one thing. Let's create one center line. Now select both the lines and the center one make relation symmetric. Trim entity, power trim, and delete this line. Okay, let's define. Now these center distance 25. Say okay. 25. And choose extruded cut feature and make here up to next. Okay. See, the hole is created. Sketch. Now let me make first circle. $82.5. Make it for construction. Again activate circle because I want to make 6 number of hole here. And this hole diameter is 30. Let's check this is fully defined. Again I am going to make one more circle. a circle pitch, and these diameter according to drawing it's 108. Make for construction, let's make circle at this point, and this circle diameter is only 10. Now angle, I have to define the angle for this. And the angle for this is 60 degree. Okay. Let's apply extruded cut feature. And here choose end condition up to next. Even though you can define the thickness. See? Circular pattern. Now first I am going to choose direction. So I am going to choose any circular edge. Let's say this circular edge. Now feature to mirror. I am going to select one, and this already selected. Now here I am going to choose equal spacing 360 degree and 6 number of instances or 6 number of holes. Okay. That's it. Now I think we did all the holes and everything. Okay, cancel it. Do you want to save changes? Yes. Save as. Now I have to save this one in 2 stage. This is save as gear D. Close. Delete those relations. Okay. Rotate those components. Okay. Now first make matte. Now I want to fix here, so select this face and this face. Concentric relation, coincident relation. Okay. Similarly, let's say this wall and this wall. Coincident relation. Okay. Now select this face. Okay, leave this clear. Now I am going to select this shaft face, because I am going to attach with shaft. This face. Coincident. Okay. Now we fixed our one gear. Okay. Let's save this one. Now let's bring our third gear, the small gear, gear C. Gear C, 18 number of teeth, 2 module, everything is same, face width 15. Let's see the drawing for this. Okay, here we have. Okay, we have to do some modification for this. Okay. First, one side we will extrude 25 diameter, depth 4 millimeter. Okay. Then we will extend 20 diameter, depth is 11 millimeter. There is 1 millimeter groove. Similarly, this side 2 millimeter depth, but this diameter you will see here 29. See. Then 25 diameter, cut out 20 millimeter. This one we need to extrude up to 15 millimeter. Then 20 die we will extrude up to 15. There is one groove also from 10 millimeter here, this is all 18 die. Okay, so let's do this gear first. Again, spur gear. Now now here number of teeth is only 18. Now rest same, pressure angle, face width, and this is we don't need because here we need to add some, say okay, and here choose cancel. Now click on the part, open. Yes, I want to change it. Let's change background. Now let's start from this face, sketch. Let me draw here two circle. The bigger one is 25 and smaller one 20. Okay. Extruded boss base. Now here in selected contour choose outer one and make the depth only 4 millimeter. Okay. Again I am going to select the sketch, extruded boss base, open selected contour and choose inner circle. And this one make total length is 4 plus 11. It's going to be 15. Okay. See. Now here we have a groove. So let's check this plane, sketch, fillet, smart dimension. This is going to be 1, say yes. I want to change it 1 millimeter. Okay. Now groove diameter. Now here groove diameter is shown 23 millimeter. Oh sorry, 18 millimeter. Activate revolve cut feature. Look, by default system took this center line as a axis of revolution. 360 degree. Okay. Here we cut. Okay, let's make start from here. Let's make gear. So I am going to choose from here a sketch. Now here also I am going to make two holes, 2 diameter. The bigger one is going to be like 29 and 25, and then last one 20. There are 3 diameter. Circle. First 29. $25 and then 20. Let's check. Okay. Extruded boss base. Now first in selected contour choose the outer one. The bigger one we need to make only depth 2 millimeter. Say okay. Again we need to use same sketch, extruded boss base. In now next time I am going to use the middle one, middle circle, and this is going to be used let's say 2 millimeter plus 15, it's 17 millimeter. So 2 plus 15. Okay. Again I am going to use the same sketch, extruded boss base. In selected contour I am going to choose the last one. Now last one is if you are going to see the total length, it's 15 plus 15 plus 2, it's 32. Say okay. See, now here we have one groove. So let's say same plane, sketch, groove. Now depth for this, edit 1 millimeter. Now 10 millimeter from this outside. Okay. Center line, let's make diameter. Similarly 18. Revolve, cut. Look, you will see the preview. System took this center line as the axis of revolution. In direction 1 I am going to keep any rotation, any direction you can keep, because there is no issue. Okay. Now let's see, we almost ready our gear. Now let's check the, okay, the 10 millimeter is just outside from cutout. That's fine. Now here we need to one cutout 20 millimeter for this 15. This is the feed. Now select this face, sketch. Now select outer line, convert entity. Activate here line. Let's make one center, exit, again line. And activate mirror entity. Let's select this line. Make sure selected copy and mirror about this line. Okay. Make sure this line is as a construction line. Let's say smart dimension. Now this center distance, this is given 20 millimeter. Trim entity, power trim. Now I am going to trim unnecessary line. Okay. Let's add again the circle distance. Okay, maybe some distance missed. So one side, make sure it's 10 millimeter. Extruded cut. Here choose up to face surface and up to this surface. But I am going to choose flip side to cut. I want to cut these two sides only. See? This is how we need. Now this is what our output. Let's save as. Now this is going to be saved as a gear C, and let's two-stage gear reduction. Okay, cancel. Now we have one gear here. Save this assembly also. Now let's bring the another gear, then we will connect. This is gear B. Gear B like 56 teeth, 220 and rest 15 is width. Then there is one depth cutout 3.5 95 millimeter. Then there is 7 number of holes 20 diameter. Okay. Similarly, there's 7 number of small holes 8 diameter. Then there is a cutout 20. We can do it like this 30. Okay, let's see how we can do it. Spur gear. Now, module 2, number of teeth 56. Now it's going to little bigger. Rest everything as it is. Say OK and cancel. Click on the part, open. Yes. Now first select this face sketch. I want to make a hole here. And the hole diameter is shown 95. Extruded cut, and according to drawing the depth is 3.5. Keep end condition blind and make depth 3.5. Similarly, I am going to use this sketch. Extruded cut, start surface, select this. See here, blind 3.5, but this is moving wrong direction. Change direction. Okay. Okay, here we go. Now again let's make some 30 dia hole. Now this outer diameter is going to be 35. Extruded boss base. Now 3.5 this direction, reverse. Okay, from this side, let's say 15 minus 3.5. 11.5, let's check. Okay, that's perfectly going to. Okay. Now let's make hole here. Now the hole diameter here shown 25. Line, make sure the line horizontal. Okay, let's make one center line. Mirror this line, select this line, make sure you selected copy, otherwise it will just move. Okay, let's make trim. Okay, smart dimension. Say okay and make the center distance 20. It's still not defined, so let's make one side 10. Now it looks fully defined sketch. Activate extruded cut feature. Here choose either next or either up to through all, that's fine. Some relations deleted, no issue. We will image looks so dull, so make edges sharp. Okay, that's look better. Now select this face sketch. Now we have to make some hole here. So first I am going to make a pitch for the hole. Now the pitch circle for the hole is 65. Make it for construction. Now again I am going to, okay, let's this time let's make a 20 diameter hole. Okay, extruded cut, make up to next. Okay, see, circular pattern. Now feature, I am going to select this. Now direction, I am going to choose this circular edge. Now here we need 7 number of holes, so keep 360-degree equal spacing and 7 number of instances. Say OK. Similarly, select this face, sketch, circle. Now the bigger diameter, pitch for this diameter, let's say it's going to be 84. Now here choose for construction. Make sure this one connected with tangent line. Okay, that's fully defined. Now place that's fine. Now we have center point. That's it. And this diameter is 8 millimeter. That's fine. Extruded cut. End condition up to next. Say OK. Use circular pattern. Feature this hole for reference direction. This circular edge, 7 number of holes we need, 360-degree equal spacing. Say OK. Let me save as. Now make this one desktop. Okay, 10, it should be 10, 11, and this is going to be 12. Now this is going, let's say 10 point gear B. Save. Cancel. Close and delete those relation, or just mute. Delete those relation, so it won't going to affect our life. Let me save. Now let's fix with this. Now activate mat. Now select this one. Okay, edges are not seem sharp, so let's check our image quality. Is it good? Okay, that's fine. Now let's select this hole and this one, coincident relation. Similarly, I am going to fix these retaining spring with this. Select internal hole and select, let me select this internal hole. Okay, let's I want to choose let's take out. Now let me select this face and this face. You will see this is going to attach with this. Okay, now let's check up to here. Okay, now here I want to fix some big gear like this gear. Let's select the circular edge and let's select this circular edge. concentric relation. Okay, now select this back wall and let's check which one is available. Select this one. Okay, now before going to apply further, I am going to add, there is one more part. Okay, this one, mat, let's say this circular edge and this circular concentric. Okay, still we can take out. Select this one, this one. Fine. Now let me select the back face of ring, retaining ring, to the cosmetic bearing. Now it's going to fix coincident relation. Okay. Okay, let me save this one. Now we have to fix this inside. Now let me, this is okay, let's hide this main body. Okay, that's perfectly going. I'm going to choose this face and with this face I'm going to fix with this outer face. Coincident relation, say okay. Now see, now both moving together. This is what we want. Now again I want to fix those spring. Press Ctrl key, make copy for this, because the same thing we are going to fix here. And retaining ring, see, Control, even though let's bring 20 millimeter. Mat, select the internal face of ring and here select the internal face of this groove. Okay, select this face and this face, coincident relation. Now the ring is fixed with this. Similarly, select the bearing internal face and this one, concentric relation. Okay, I'm going to choose bearing face and this face, coincident relation. Okay, that's fine. Now let's bring the first gear, pinion. Gear A, pinion. 17 teeth, module 2, pressure angle 20 and face width 15. But you will see the drawing here. Now let's check this dimension. Gear is same, but we have to add this kind of shaft. 20 millimeter, 80 millimeter groove diameter. This total length 15, gap 10. There is 1 millimeter groove. There is chamfer also at both the end, 0.5. Then come here, 20 diameter up to 21 plus 11. Then 100 millimeter up to 19 diameter. There is a groove cut out. You will see 4 millimeter, depth 7 from here to center point, 75 millimeter long. Okay, there is one more groove with 1 millimeter diameter. So let's check this. First bring gear. Now this is going to be the first gear, so module 2, and teeth number of teeth is only 17. Rest everything same. Say okay. Again system asks would you like more? Say no. Open. Now here I want to add okay, so let's select back sketch. Let me do one circle, and this back side diameter is going to be 20. Activate extruded boss base and add up to 15. Okay, the groove we will make later. Let's add some more here. First 20, then one more add 19. Okay, extrude. Now here in selected contour, let's choose only outer. Fine. The outer one we need to extrude up to 21 plus 11. This is going to be 32. Fine. Again I am going to use the same sketch. So select and activate sketch, extruded boss base. Now this time in selected contour choose internal, and going to start from surface. Select this surface. Look, and the total length 100 millimeter. See? Okay. Now let me check which plane is this. Okay, plane 1 sketch. Now let's say line. Go back to the point and see the line is converted. A smart dimension. Now select the origin point and this one. Now the gap 7 millimeter shown, so we will make 7 millimeter, and this length shows 75 millimeter. Okay, now let's make this point tangent. Fine. Extruded cut. Here choose mid plane and depth only 4 millimeter. 4 millimeter, 2 millimeter one side, 2 millimeter other side. Say okay. See here, I'm going to change this image quality. That's fine. Now let's try to make those cutouts. Plane 1 sketch, fillet. Now here, and we have one cutout at here. Let's make one center line for revolution. Smart dimension 1 millimeter. Fine. Distance from here to here, the center distance, so let's say 18 millimeter. Similarly for this, 18 millimeter. One. Okay. Now the important thing is 1 millimeter. Make this one 10 millimeter. Fine. Now from this side, 21 millimeter from inside. Revolve cut. Look, by default system took this center line as a axis of revolution. I want to make a complete 360 cutout. So here by default 360. Okay. Let's make chamfer. Angle distance. Here we have to choose. Here we have to, in chamfer parameter, let's say 0.5, 45 degree. Let me choose these two ends. Okay. Now this is ready. Let me save this one. Gear A. And this is going to be part number 13. Gear A, pinion. Save. Cancel. And here we go. Now again let me bring some more retaining 20 millimeter. Open. Use control key and copy this. We need 2 here. And also you can copy this control C, control and select this one and drag, copy. Now first let me fix some ring here. Mat. Select the internal face of ring and this internal face. Concentric relation. Yes. Now select this face and this face. Coincident relation. Now one ring is fixed. Let's fix other ring also. Concentric. This face, this face. Coincident relation. Okay, this one and this one. Concentric relation. Now, okay, better to add this face with this face. Coincident. Okay, we missed something. Undo. Now we will select this face and this face. Coincident relation. Okay, that's fine. Now let me select mat, this face, and here In casing, select this bearing internal face. Okay. Now let me select this face, ring face or bearing face. Okay, cancel. Let's hide this casing and let's see the alignment of gear. Okay, now this perfectly in all the gears are in perfectly aligned. Now it's time to add some what we called. Okay, here again press Control and drag this bigger bearing mat, concentric, and I think the position is same. Let's select this face and this face. Okay. Now I am going to again select Control key, drag and make one more ring. Let me select internal face and here let me select internal face, concentric mat. Okay, select this face and this face, coincident relation. Okay, that's fine, perfectly fit. Now outer casing we will make at the end. First we need to make some important relation with gears. Okay, now let's start to create a gear mat between this. So I'm going to keep this gear near to this so that don't try to collide it. Okay, now let's activate mat, mechanical mat, gear. Now here I want to select two faces of this. So I am going to put here number of teeth. So I am going to use this face of this teeth, and for second face I am going to choose this internal root diameter. Then here I am going to change ratio. Let's say I am going to put teeth 17 and this one 56. Say okay, cancel. Let's say is it work? Okay, that's fine, it's working. Okay, now let me hide this and let me align according to teeth position. If you can make tangent relation, okay, otherwise no need to define much. Oh, that's fine. Mat, mechanical mat, gear. Now same, I am going to select the face of this teeth and the root diameter of this. See here. Now I want to put teeth, so 18 teeth available on this and the bigger one have 73 teeth. Okay, cancel. Just check, is it working? Oh, that's fine, it's working. See, okay, let's see, show. Okay, we fixed each and everything, even show. So this is the two stage to reduce the gearbox speed. This is input shaft, this is output shaft. see the input speed is higher and the output speed is lower. Now let's bring the last component. Okay, activate met. Now I am going to select this bearing, upper surface and this surface, concentric relation. Okay, similarly let's take out, select this bearing, upper surface, similarly this bearing, concentric relation. Okay, let's fix. So how you will fix? Bearing this face and this inner face. Okay, see, cancel. Now select this one, change transparency. Even let me hide this. Now I am enjoying this. See, the small gear is rotating too fast. Show. Let me save this one. Just directly go to motion manager. Okay, let's drag this one 6 seconds and I want to apply a motor on input shaft. I'm going to keep this one animation here in motion studies, let's say 50 frame per second. Okay, activate motor. Let's keep this shaft rotary motor, constant speed 100 rpm. Say okay. Now it's calculating. Now let's here choose calculate. Drop down and again play. See how this speed is higher, this speed is slow. Even edit, before going to edit, let's take back position, edit motor, and I'm going to reduce, let's say 50. Again calculate. Play. Now this looks perfect. Don't forget to share and like our video and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.